Welcome to my van and RV power system Q&A session. I'm going to be reading off some questions that I got on a recent survey. I asked everybody what they'd like to learn about the most, and we had some popular topics at the top, but there was an other category at the bottom where you could ask a random question, and I've got all of those other questions here today, and we are going to dive into it. So hopefully this will help you if you ask the question, or I think these will be highly useful to everybody else if they are looking to build a van or RV power system. We've got some discussions here about some of the latest components. So without further ado, let's go ahead and dive in. Question number one is using an all-in-one power center in place of an electric build. So this is a common question that I get. A lot of people want to eliminate all of the design and installation that they would have to do in a custom electrical system, and they want to go with a Bluetti or a EcoFlow Delta or something like that. In the past, the limitation with the all-in-ones was battery capacity. They've mitigated that to some degree by allowing you to purchase additional modules that expand the battery capacity, which was kind of a natural progression because I think electrically that's pretty easy to do as far as adding more batteries in parallel. The main limitation I see is they are branded as solar generators, which is fine. They're going to have the inputs for solar, and they're going to be able to manage usually sometimes up to 600 watts of solar, a good amount of solar, but they're often missing the DC to DC charging of alternators. So they have chargers to charge from the power grid and from solar. So they've kind of picked those two charging sources, but what's missing is the DC to DC alternator charging. And I used to work at a van shop, and the owner didn't know a whole lot about electrical systems and was looking for easier ways to do things, which can't blame him. You want to do things faster and for less cost and all that stuff. But it really was the alternator charging that was a challenge, and you need to restrict the current to protect the alternator. And in the case of the van shop, what we came up with was using a DC to DC charger to feed an inverter to boost the power up, and use the inverter to feed the high voltage input of the all-in-one. The EcoFlow Delta is what we were looking at. So it just gets kind of ridiculous trying to run all that circuitry to do the DC to DC power. So if it were me and I was going to go with one of those, I would make sure that the inverter was really going to run what I needed to run. Don't play around with the battery capacity. You're going to need to still do some calculations, figure out how many watt hours you're going to need on a daily basis. Take the watts of your appliances, multiply by the hours that you're going to run those appliances each day, and then add those up, get a total, and really look at the watt hours that are going to come in these all-in-one units. And if it's not enough, go ahead and price out adding that additional battery module. So those are the limitations. No DC to DC charger and not enough battery capacity. Sometimes the cycle life is a little bit low. I don't know what battery chemistry they're using, but you should be getting several thousand cycles. But I've noticed with some of the all-in-ones, they say like 500 cycles. So that's something else to look out for. But I could not find the brand, but one of the brands emailed me the other day. They wanted to give me one of these all-in-ones, and it had a DC to DC charger. So they are out there. But I would make sure that it has that if you're going to put it in a vehicle, because solar is good. Plugging into the grid is good. But if you don't have alternator charging, your system is a step below where it should be. So I would just look for that. And the other thing, EcoFlow has come out with the RV kits, which are plug and play. I was on their website the other day, and they didn't have, I couldn't really find the kits. I had to kind of search, and eventually I found them, but they weren't featuring them at the front. So I don't know how well that's going, how well those are selling. They look like phenomenal kits, and I would check out the EcoFlow plug and play RV and van electrical kits. That may be kind of a hybrid of getting that all-in-one plug and play functionality, but giving you enough battery capacity, and the DC to DC charging is built into those kits. So check that out. But I'll go ahead and move on to question 2, integrating power stations, EcoFlow and Bluetti into your system. So I did not see that. Very next question is pretty much the same. Reference question number 1. But looks like that's a popular topic. If you're getting a lot of value out of this Q&A, I wanted to tell you real quick, I have a resource that may be useful to you called the Ultimate Van Power Cheat Sheet. It's got a discussion of the 3 major charging sources for van and RV power systems, which are solar, shore, and alternator power. And it's going to talk about how they each have strengths, but they each have weaknesses as well. But when you bring them together in a holistic power strategy, it's going to make sure that you're covered no matter where you go out on the road, so you can enjoy what you went out there to do and you're not going to be worried about your power system. There's also a discussion about different battery chemistries and the strengths and weaknesses of different battery types. That's going to help you narrow in on which battery type is going to be right for your project. And then lastly, there is a really cool diagram that shows your entire system on one page. It's going to show your 3 major charging sources at the top, how that power makes its way through the system, charges your battery bank, and then comes out at your end devices such as your microwave or your phone charger. For instance, how does the alternator power make its way through the system and come out and charge your cell phone? So it's a really illuminating diagram that I think you'll find useful. That is included with the Ultimate Van Power Cheat Sheet. To grab your own copy, all you have to do is click the link below or go to rosslukman.com/vanpower. All right, with that, let's continue here with our questions. Question 3, limitations of state of charge monitors, float or not to float. So I'll take the first part of that. Limitations of state of charge monitors. There aren't a lot. I would get a high quality battery monitor with a high quality shunt. You could go with Renogy or Victron for that, but they tend to be pretty accurate. I mean, I don't know if I'd launch a space shuttle with them, but they tend to be pretty accurate on the state of charge. So just get something quality. Don't try to spend $20 from some random brand on Amazon. And then float or not to float. Lead acid batteries, you definitely want to float. Lithium batteries, I think that's what you're talking about here. You don't have to. Some of the chargers you can't turn off. They ask you for a bulk charge voltage and a float voltage, and you just have to give it to them. But if the battery is charged up at the bulk voltage to 14.4 volts or something like that, and then it goes into float and it drops it to 13.6, there's not a lot of current that's going to go into that battery. It's going to kind of maintain it, but there's not going to be a whole lot of action because the battery has been lots of current has been added. The battery voltage has been raised up to 14.4. So when the charger drops to 13.6, not a lot's going to happen. Now, as far as long term, as far as storage for lithium batteries, typically just run them down to 20%, down to 80% capacity or 50%. And I would just turn everything off and turn the switch. Having them maintained on a float charge for a month or 3 weeks or whatever, it's not needed. It's not needed. But when I guess I would say when you're actually using the vehicle and you need those batteries ready, a float charge is okay and not a whole lot of current is going to flow. But it is going to keep the batteries at 100%. And I would do that when you're using it. Don't do that. Turn everything off when your vehicle's in storage. So that's what I would say on that. Question 4, on the alternator, the problem is most modern day vehicles cannot recharge/run all devices we have in the van, camper, or truck. Plus, with smart alternators, rules are not just hook up the alternator and have recharge power. So I agree. The smart alternators are going to have a high voltage sometimes, and then they're going to drop way down other times. The best thing to do is add a DC to DC charger. They all have provisions for smart alternators now. You're just going to put it in that setting, and it will basically operate at a lower input voltage, maybe 9.5 volts or 10 volts. And they have a buck boost functionality, which means they will raise or lower the voltage. And so they'll take that input voltage and boost it up to something else that your battery needs. And the DC to DC chargers are going to take care of the smart alternators. And it says most modern day vehicles cannot recharge or run all devices we have in the van, camper, or truck. It depends on what the device is. Sometimes the alternator can, if you have a 40 amp air conditioner that's pulling 40 amps and you're getting 60 amps off the alternator, it'll run that air conditioner while you're going down the road with a surplus of 20 amps that goes into your batteries or goes into anything else that's running at that time. So it depends on the size of the alternator and the size of the load, but oftentimes it will run that load. And then if it doesn't, it will dip into your battery capacity. The batteries will help the alternator, and together they will run the load, assuming you are idling or driving down the road. But in general, you're going to recharge the batteries, and then the batteries are going to provide however much power. It could be below what the alternator is providing, could be above it. That's just a recharge source. The batteries are going to pick up the slack on anything the alternator can't do for live loads that are running while the alternator is running. I'll leave it at that. Question number 5. All of the topics from the survey would be great, but we'd like to see more of the other manufacturers' systems components, not only one promo manufacturer. Not everyone can afford the most expensive components. So I assume that you're talking about Victron because that's the brand that's all over my channel. I will say that they just cut their battery prices in half January 1st, 2024, which was crazy to see because I was actually making a system design at the time and I had my prices in there. I was putting the prices and I went and checked and their battery got cut in half, and then all their chargers and everything, the solar chargers, the inverter chargers, they all went down as well. Not cut in half, but they all dropped. So I think they're trying to be more affordable. They're still at the high end. Honestly, everybody thinks that Victron is sending me stuff. I like to build systems that are a little bit higher end, and then also I sell training and engineering services, and so I don't use the cheapest stuff. One, because I don't want phone calls that your stuff failed, but also I'm attracting people that want to build something nice and they're not the most price sensitive people. I've been doing this for quite a few years and I've dealt with people that were wanting to do something on the lower budget end of things. And there are a lot of difficulties. Sometimes I would have to re-engineer systems to make them cheaper for people. And it just causes a lot of problems. Sometimes you have to do extra engineering to cut costs and it just doesn't equate because those people don't want to hire me. So I tend to trend towards the higher end stuff. And like I said, it's so that what I recommend doesn't give me a lot of callbacks or emails that your system shut down in the middle of nowhere. Yeah, a lot of it, I'm kind of just featuring products on my channel that I think that people, I'm looking for the customers that Victron is looking for, which are people that want to build something a little bit nicer. So I featured a cheaper battery recently and it kind of attracted a bunch of people telling me to feature a bunch of cheaper stuff. And I don't really like that. So I would just say on YouTube, there are a lot of people featuring like budget brands and I don't know, there's kind of YouTube videos on anything now. It's crazy the amount of resources on YouTube. So I would just say find people that are featuring those cheaper components. But yeah, that's all I'll say on that. Question number 6, using / charging LiFePO4 batteries in a motorcycle, car, or quad. That's a little bit difficult. It's a little bit outside my wheelhouse because if you take a system that's made to charge a lead acid starter battery, I'm thinking we're talking about the starter battery here. If it's lead, then that alternator, it may be a direct electrical connection with no current restriction. I would just say, usually, so your DC current coming out of the alternator, you can intercept that with a DC to DC charger that's going to restrict the current. Or, worst case on some of these some of these retrofits, I just tell people, or I don't tell people this, but this is what I would try. So take this with a grain of salt, but sometimes you can put the lithium battery in there and just see if it blows any fuses. You can check the current. You can have a clamp meter, a DC clamp meter, see how much current is flowing between the alternator and that lithium starter battery. But just see, does it overload the alternator? Is it too much current? Do you need to add current restriction in that line? But in general, I would say you're often going to have to add some kind of DC to DC charger to restrict the current, because lithium batteries will pull more current from that alternator than that vehicle was designed for. That's the theory, but you can check it, put the lithium battery, see if your fuse blows. If you don't have a fuse in the line that you can see, go ahead and add a fuse. 80 amp fuse, 100 amp fuse, whatever you want to be the maximum. Maybe undershoot it a little bit, put a 50 or 60 amp fuse. And if the fuse blows, it's overloading. So it may take some experimentation, but in general, lithium batteries are not directly connected to a small alternator. Question number 7. I have a 24 volt system in my RV and the integration of 12 to 24 volt is challenging. Not sure why 12 volt systems are taking market share. I don't think they are taking market share. I think 12 volt is the legacy technology that has been around for like 100 years. So all of the starter batteries and all of these vehicles, they use a 12 volt battery to start the engine. I guess 100 years ago, it was enough voltage to crank the engine. The voltage is force, so it works to start the engine. And so all of your vehicle electrics were set at 12 volt, all the little lights and stuff like that. So 12 volt is just ubiquitous in these vans and RVs, and a lot of components run at that voltage. There's nothing wrong with 24 volt. It's just a lot of your components like lights and pumps and stuff like that may not run at 24 volts. And so you've got to step down the voltage. You're adding a converter that has efficiency losses, and it's a potential failure point. It's not a huge deal. I would just add a converter. A lot of them are pretty affordable, pretty inexpensive. Like I said, there's a slight power loss, but 12 volt systems are just legacy, I would say. There's a lot of manufacturing around the components and the batteries, and it's just a very established voltage for vehicles. So I'll leave it at that. I hope that was helpful. Question 8. I have a Coachman Beyond with AGM battery and generator. I would love to see a video series on how an existing system can be upgraded to lithium, especially around using existing components, Xantrex inverter charger, for example, that work with lithium, and added components necessary for the upgrade. So kind of like the question on adding lithium to a motorcycle or a quad, you're going to want to restrict that alternator current. If you're going from the alternator to lead acid, typically you could do that straight. You would have an isolator that was basically just a little relay and just sent that power straight through. With lithium in general, you don't want to do that. You want to add some kind of current restriction with the DC to DC charger, and it's also going to have a charge algorithm to adjust the voltage that's coming from the alternator. So that's the main thing, is the alternator charging. You got to add that DC to DC charger in the line. You can often reuse the cables. The cables are there. You can splice into them, add your DC to DC charger right in the line, just to add that. You're adding a choke point to slow down the current. But the other question on the inverter chargers, it often comes down to your specific vehicle and what inverter charger you have, whether it can handle lithium, whether it has a lithium setting. For the equipment I use, it just has a lead acid setting and a lithium setting, and I would just change the setting. But some of these older RVs, they say that their inverter charger is not lithium compatible. In that case, kind of like I told the guy with the motorcycle, you can try it out. You can put lithium batteries, see how your inverter charger does, see if you blow your fuses. Some of them, I remember when lithium first came out in 2017, we used a Renogy inverter charger in a Sprinter van in California. And basically they said, this does not do lithium, does not do lithium. And we came to find out later that it kind of did do lithium. It kind of did do okay. And I think Renogy, before Renogy came out with lithium-specific inverter chargers, there was a way that you could make that inverter charger work. You could maybe dial down the current, the charging current from the inverter charger. So you may be able to adjust what you have. Again, check your fuses. If more current flows than it's supposed to, put a lower rated fuse in there that will blow. Do some testing with it. But if it just absolutely will not work with lithium, then yeah, you have to change out your Xantrex inverter charger or get a lithium edition Xantrex. And all the connections are the same. The wire doesn't change. Your 120 volt or 230 volt cables are going to be the same whether you have a lithium or lead acid inverter charger. And then your cables running to the batteries would generally be the same. Your fuse sizes are based on the cables, and you may get a bigger inverter charger and it says give us bigger cables, and then you have bigger fuses and stuff like that. But it may be swappable for a lithium capable inverter charger. But those are the two main things. Some of these RVs have a converter, which is basically just a battery charger. It's 120 volt or 230 volt down to 12 volt or whatever your battery voltage is. Some of those converters are not lithium compatible. You can swap them out, but once you get the lithium compatible one, it can use the same DC cables that go to your batteries, and it can have the same AC 120 volt or 230 volt input cables. So a lot of this stuff can go right back into the circuit where it came from. You just need something that's lithium capable, and lithium capable stuff is usually just restricting the current somehow, because lead acid had a higher impedance, and it had kind of a natural current restriction to it, but the impedance of lithium is much lower, and so it'll suck up so much current that it just blows fuses and things like that. So a lot of this like lithium capable equipment is it restricts the current somehow. And maybe the charging voltage is a little bit different for lithium, or they have a custom charging profile that you can set your own voltages. But in general, the voltages are almost the same between lead acid and lithium batteries. Of course, it's better if you have a custom profile that you can pick your own voltages. But in general, the voltages are not going to change a whole lot between lead acid and lithium. It's mainly the current restriction that you're looking for. So hope that helps. Question number 9. Use and connections for 2 alternators. So typically if you have 2 alternators, one of them just runs the vehicle. It's going to recharge the starter battery. It's going to run the vehicle computer and all the little lights and stuff for the vehicle. And the second alternator would not be connected to the vehicle electrics at all. It's just going to have cables that go to the back and just completely bypass the starter battery and the vehicle computer. It's going to bypass all that, and it's just going to go to the back. Now, on the negative, they may be both bonded to the chassis, so they will not be completely isolated from each other. But in general, the current from the factory alternator, stock alternator, is going to feed the vehicle and the engine battery. The second alternator is going to feed the rear batteries, and they don't need to communicate beyond that. So I'll leave it at that. The second alternator, typically I would get an external regulator such as the Arco Hercules or the Wakespeed WS500. Get an external regulator. Don't get an internally regulated second alternator, because that's going to put out a flat voltage like 14.0 volts, and you really need to send that through some kind of DC to DC charger to regulate it. That charger is going to be $1,000, because the second alternator could put out maybe 200 amps, something like that. So you need a big DC to DC charger to handle that much amperage. And it's just kind of not the right way to do it in my mind. You want to have that externally regulated second alternator and hook it up to a control box. It could also be a Balmar, Wakespeed, or Arco. They make external regulators. Arco has the new Hercules that just came out, so definitely check that out. And that also connects to the Victron Serbo GX or Econo GX, and it will report what your second alternator is doing and log that data with the rest of your power components in your GX device. So I'll leave it at that. Hope that made sense. Question number 10, automatic transfer switch for 2 inverters, genset, and power pedestal. So the automatic transfer switches you need for, if you have 2 sources, you need 1 switch. If you have 3 sources, you need 2 switches. If you have 4 sources, you need 3 switches. So each switch switches between 2 sources. So it looks like you have 4 sources here. That would be 3 switches. Now the other thing is, oftentimes you'll have an inverter charger that has a switch inside of it. It's switching between the inverter and shore power. Now you can go upstream from the inverter charger and do a transfer switch before that, and that could be like generator and shore power. Whatever exits from that transfer switch goes into the inverter charger, and it's the inverter charger, it thinks it's shore power. It could be generator, it could be power grid, but to the inverter charger, by the time it arrives there, it's shore power. And then the inverter charger is either going to hop onto that shore power if it's available, or if that goes away, it's going to go onto the inverter and pull from your batteries. So basically you have 4 sources, you need 3 transfer switches. One of those transfer switches can be the one that's included in an inverter charger. So I hope that made sense, gave you a little help there. Question number 11, basic system for a 30-year-old camper van, no bells and whistles. Man, I worked on a 20-year-old camper van at the van shop, and it was intense. You have some forensics because you got to kind of see what's in there. I mean, it wasn't too intense, but you don't have a blank slate. You're kind of pulling things out, figuring out what to leave. It's not that hard. I guess I just feel like when you say basic system for a 30-year-old camper van, you're thinking like it's going to be simple or whatever. To me, basic system doesn't mean anything. I hope I'm not being rude, but it's not that much easier than a complex system because you still have to know why it works and what to put. So I don't know, maybe contact me for help. And I do charge for help. I don't know if that's clear. When you make a bunch of videos on YouTube, everybody thinks you're just like hanging out. It's like your hobby. But I do offer engineering services and training for power systems. So contact me if you want more help on that. So number 12, generator start with dead batteries. In general, I would say you're going to have to charge the batteries, or you're going to have to link them to other batteries that have a charge. If they are actually dead and they will not accept a charge, then you may have problems. You may need to swap them out. You could put the dead batteries in, I guess they would be your house batteries, put them in parallel with the engine, and you could have a DC to DC charger, start the engine, charge them that way. Or you could have a bypass switch, which I like to put underneath the DC to DC chargers to create kind of an emergency link to put everything in parallel. And then you could use your engine battery to crank the generator. There are different ways to do it. In general, you're going to have to charge those batteries. So I would say have some solar. But I think what you need is either a bypass to the engine and engine battery with a direct link and a bypass switch underneath your DC to DC charger. Or you could get one of those jump start things that you jump start a vehicle with. One of those could plug in. You could have some Anderson power pole connectors that linked into your positive and negative for your rear system, and that would give you an extra battery supply that is not associated with the vehicle that could start that generator. So that's my best guess without knowing the full scenario. Hopefully that was helpful. Number 13, wake speed WS500 alternator regulator. So I covered this in my recent alternator training video, but basically I feel like I can't give the full details on that here without drawing it or demonstrating it. But that is going to attach to an externally regulated second alternator, and you're going to use the VE CAN ports on the Serba GX or Econo GX to pick up what the alternator is doing, and that data can also be exported to the VRM portal. So I feel like I can't really do that question justice here, but hopefully you saw the second video in my Van Power Workshop series. Moving on, we're going to do question 14, adding a generator. So with a generator, there are a couple of ways that you can do that. You can just plug it into your shore power jack. That's kind of the easy way where you don't have to modify the rest of the electrical system, and the system and the inverter charger think that that is shore power. So you would just plug it into your 30 amp inlet on the outside of the vehicle. If you want to hardwire it like you would have in an RV where it's coming in hardwired, typically you would have a transfer switch. I mentioned this a little bit earlier, but the generator would come in and the shore power would come into a transfer switch, and then one line would go out of that and run into an inverter charger. So that's how you would hardwire it. The only other thing that I would say about adding a generator, and I had a consulting call the other day where we talked about basically, in order to operate safely, the ground and the neutral in the generator need to be bonded, and this would simulate how it's done with the power grid. And basically, long story short, if you have a ground fault in your vehicle, it will make sure that the breaker trips. When you bond the neutral and ground, it basically completes the circuit. The power goes out on the hot wire, and it is able to come back on the neutral. Even if you have a ground fault, it goes goes to ground where it's not supposed to go. If back at the generator you bond the ground and the neutral, basically the electricity is able to complete the circuit, and by doing that it overloads the breaker and it shuts down and prevents a dangerous situation. So that's the only thing I would say about adding a generator. You want to get a neutral ground bonding plug. You can just plug it into the outside of the generator. It will bond the neutral and ground, and it will operate just like the power grid does, where neutral and ground are bonded in your power panel. So you want to simulate that with the generators. Lead crystal battery information, number 15. So I had to do some research on this question. In general, it looked like a better battery than AGM, but the main thing I saw, the weight per watt hour, it was 20 watt hours per pound. Lithium, I calculated at 47 to 55 watt hours per pound. So lithium still had more than double the energy density per pound or per kilogram. And it also said 1,500 cycles at 80% depth of discharge. And I think with lithium, you could get at least double that. So lithium is still going to be twice as many charge cycles, at least half the weight per watt hour. So I think lead crystal is better than AGM, but maybe not better than lithium. And I think with the vehicles, you're kind of looking for a compact way to store a lot of energy, and you don't want it to weigh a lot because you're dragging it around. And so I think the lead crystal, if you're going to do a home off-grid system in a home and you need energy storage, could be great. But when you're dragging it around, I would say be careful of the weight. And then with the cycle life, That was a major difference between the lead crystal and the lithium. So I think it's a better lead battery, but maybe not quite lithium. So I had to have something to compare it to. So hopefully that helped. Number 16, gas LPG power units, 3,500 watts. So this is basically the generator question again. I'll reference question 14 where we talked about adding a generator, and all the same advice that I gave there would apply. So hopefully that helps you. Number 17, putting lugs on really large cables without an expensive crimper. I would just use a hammer crimper. Just use a hammer crimper if you don't want to spend a lot. Get a big hammer, hit it multiple times if you have to. It's kind of a crude way to make cables, but if you want to do it inexpensively, you can do it like that. You can also put the hammer crimper in a vise if you have one and crush it that way. But in general, I would just say on inexpensive this, inexpensive that. What I notice with a lot of people that are doing their own builds is you're already doing your own labor. So you've just cut the price of a power system in half at least. You're not hiring the expensive labor. You're not waiting on the 12-month wait list to have your stuff done. So you've cut your price in half already. And then people, they don't want to buy training. They don't want to buy tools. They don't want to buy, like, it gets a little bit ridiculous. But to answer your question, it's going to be the hammer crimper. $20. Timco is my favorite crimper brand. They have a $20 hammer crimper. Number 18, water systems, pumps, filters, and delivery. This is, I would say, I'll just give you kind of a run through. This is maybe not my specialty these days, but I'll tell you what we've done in the past. I would get a SureFlow Revolution pump, 3.0 gallons per minute. They tell you you don't need an accumulator. I like to add an accumulator to that because it adds kind of some flexibility in the line. The accumulator, you're going to pump it up to like 30 psi, and it's got a little rubber bladder in there, and it basically just smooths out the cycling of the pump so that when you turn on the faucet for a little bit, the accumulator is going to basically contract and supply that water, and the pump is going to stay off. So the accumulator is going to reduce the number of times the pump turns on and off. So I really like those accumulators. You're going to want to have a strainer on the input of the pump. That's going to increase the pump life. Make sure that it doesn't get any gravel or things in there that are going to tear up the impeller. And then oftentimes you can use PEX from a house. It's more flexible. If it freezes, it'll expand. I would say use PEX. And then for your delivery, they have some RV components, but they tend to be expensive and kind of chintzy and cheap. For your faucet, at least for your kitchen, I would go get a kitchen faucet. I do not like the RV faucets. Unless it's a sprayer at the back of the van at the tailgate, they have some spray nozzles. Those are a really good idea to, wash the dog or wash yourself or wash your feet. Some people have kind of an outdoor shower. They'll open the rear doors of a van and put a shower curtain and spray themselves back there. So in general, I would run to the rear faucet and run to the kitchen faucet. Again, on the kitchen, get something from a home improvement store that is high quality. That would be my advice on the water system. I hope that was helpful. On the tanks, they have tanks that go over your wheel well. Those are really nice because it utilizes some space that's usually your garage area. So I would go for those tanks. And then if you can hang them underneath, that saves a lot of room in your cargo area of your vehicle. But you just got to watch freezing. They have some little 12-volt heater pads from Facon, F-A-C-O-N. And they have an internal thermostat, so you just hook them up to 12-volt power, maybe run them off of a switch if you want to be able to shut them down. But they will turn themselves on and off. based on the temperature. I think they turn off at 35 Fahrenheit and turn on at 35 and turn off at 45. But that will keep your water from freezing for 4-season camping. So hopefully that was helpful. Number 19, Mercedes Sprinter considerations. Let's see. I used to not say this, but I would get the auxiliary battery if you can. They're going to have the auxiliary battery is separated from the engine battery by a little voltage sensing relay. That means you can put your loads on the auxiliary battery and you cannot get to the engine battery to drain it and get yourself stranded. They are going to tell you to use 80 amps maximum current off of that auxiliary battery system. Mercedes is kind of conservative, so maybe you could go over that, but the manual says 80 amps. If that's not enough for you, 80 amps times 12 volts would be about 1,000 watts. So give you 1,000 watts to charge your rear systems. That's 80 amp hours per hour, 1,000 watt hours per hour of driving. If that's not enough, then you would look at your second alternator. The Mercedes is good in that the punch out locations on the roof are kind of ready to go out of all the van brands. The Mercedes is much easier to fit an air conditioner or fit a vent fan, and it's got flat parts on the roof where the corrugations stop, and it's just got flat sheet metal, so you can get a good seal with an air conditioner or a vent fan. Now you may want to talk to DIYvan.com and Hayne over there and get an adapter plate anyway to fit the Mercedes, but I do like their roof setup. And they also have the roof tracks, so you can bolt your solar panels on. I don't like gluing down solar panels. I like to be able to bolt them on, and the Mercedes makes that really easy with the roof tracks. So those are about $300 if you're ordering your van new. I would definitely get those roof tracks, get the auxiliary battery. That's about it. There are a lot of options with the Mercedes. You can kind of go nuts and add double the price of your vehicle. But those are the main things. The auxiliary battery and the roof tracks is what I would get. And I hope that was helpful. Number 20. I have a Bluetti AC300 with two B300 batteries. Okay, so you have the Bluetti with the expansion batteries. How can I keep them warm when the van is sitting in the driveway? For this, what I would do is get one of those little 120 volt to 12 volt adapters. It's basically just going to be a little plug that has a couple of wires coming out, and it may go to like a 12 volt socket. I would clip off that 12 volt socket and connect one of those Victron heater pads to it. And basically you're going to be able to run an extension cord, plug this into your house or your garage. It'll step down that high voltage to 12 volt and it'll run those little 12 volt heater pads. That's what I could do. That's what I would do. If you can find 120 volt heater pads, you could do that so there's no conversion. But I would go on Amazon and get a, something that plugs into the wall that outputs 12 volts DC and just butt splice it to a 12 volt DC heater pad. So I hope that helps. Number 21, programming the different Victron components. While the defaults may be fine for most setups, I would still like to understand the different settings and choices for their smart components. I would say this is kind of advanced. I will say that the settings across different chargers will be similar. So like your bulk charge might be 14.4. That's going to be decided by your batteries. That's going to apply to the solar charger, the DC to DC charger, and the inverter charger. That's going to be your bulk setting, and then you're going to have a float setting. There's a 35-minute video in my program showing the programming of the MultiPlus from Victron and going through all the little settings. This is something that's it's kind of the implementation stage, and you're really going to find that in a course, an advanced program. So I would just say you kind of alluded to this on the default settings. I'll often turn my chargers on. They can be on in the default, the factory default, and it won't hurt. If it's set for lead acid, it won't hurt lithium batteries. You can turn everything on and then kind of program it later. I'll say that just for everyone's general knowledge. But yeah, I guess this was something that I could have covered in my recent video series, but I would say this is something you're gonna probably get in a course because it's too much minutia for people's general interest. But thanks for the feedback on that. So hopefully that was helpful somewhat. Sorry. Number 22, this may be covered under alternator power. DC to DC chargers would be helpful. Okay, so this person wanted DC to DC chargers. That was covered in my recent video series. I'll just say the Orion XS has come out from Victron, or it's about to be out, and it runs cooler than the previous Victron generations. It's 50 amp instead of 30 amp, so it's a little bit more output, and it's also programmable to reduce the output, which the old chargers did not have. And it also has a VE direct port, so that it can run a communication cable over to a Victron Servo GX or Econo GX, and it can report your alternator data. So that was also not on previous generations of the Orion chargers. So definitely check out the new Orion XS. Sterling has some DC to DC chargers coming out that they've got different variants that go from like 48 volt to 12 volt, 24 volt to 12 volt, 12 to 12. They've got all different sizes, a lot of variants. And if you want to run those with the Victron systems, that power ends up getting picked up by your battery monitor, your shunt. So that's where you see that DC power coming in, and it's going to tell you how many watts are coming in off of the alternator. So that's how I pick up power with the Sterling chargers on a Victron system. But they have a lot of options there. They also have a couple of features such as reverse charging. So it will charge your engine battery when the vehicle's just sitting there. Let's say you have solar power coming in. It'll trickle charge your engine battery with the Sterling chargers, which is very handy. And they also have jump start assistance where you could hit the button and it will use your rear batteries to start the vehicle. So check out sterling-power.com or sterlingpowerusa.com. I'll leave it at that. Number 13, is there a way to charge a lithium battery bank at a charging station for electric cars? So I got this question from one of my students a while ago, and I had to do a lot of research because I do not have an electric car at this time. And basically, when you plug in at a charging station like a Tesla, the vehicle computer is going to communicate with the charging station, and it's going to adjust the voltage and the current, and it's basically going to use that charging station as, you know, a charger. So they have to communicate, and you'll notice on the car charging charger that you plug into your car, it's got two ports for power. Or I don't want to sound ignorant here, but it'll have two DC ports, two AC ports, I believe, and then it'll have like a communication port. So that communication port is kind of a sticking point. I think one of the all-in-ones, like the EcoFlow or the Bluetti, they did a provision where you could charge off of a charging station. But in general, for like the Victron systems, it hasn't been done yet because your system has to communicate with the charger, and those chargers will put out like 250 kilowatts, like 250,000 watts, and your little 400 amp hour system cannot handle that. And it's also, some of these, like the Audi, runs at 700 volts DC power. So the charging stations are made to put out 700 volts. They're not going to put out 14.4. None of the electric cars charge at that. So if you had that communication protocol and your system could tell the charger, like, give me 14.4 volts and, 80 amps or 100 amps or whatever, the charger could adjust and do that, because those charging stations, a lot of them are made to charge different vehicles that are running at different voltages. So they talk, your system and the charger talk. So as you can tell, it's kind of an interesting topic. There's a lot of nuance to it, but if your power system cannot communicate with those chargers, it doesn't know what voltage to send, how much current to send, and they are sending, you know, if you have a 1,000 amps at 250 volts or whatever, that's 250,000 watts or whatever. It's just orders of magnitude more than these little camper van and RV battery banks can take. So in general, it's not there yet. I hope that was helpful. Number 24, give an overview of the communication platforms and when to use them. Why Bluetooth? Okay, so I'm going to go with the monitoring, like the Servo GX or the Chrono GX from Victron. They are going to have all the chargers in the system and battery monitors hardwired to them. So nothing's wireless. It's all going to use some type of cable. It will output a Bluetooth signal to you, to your phone, so you can check it within 20 feet. So that's all Bluetooth is it's local monitoring over using radio waves. It's going to allow you to check on things within 10 to 20 feet of your power system without having to go to a screen on the wall that's hardwired to your power system. So that's your Bluetooth. If you can get the system on Wi-Fi, it can upload to the internet, and that's where the VRM portal, the Victron Remote Management Portal, comes in. And now you can be on the other side of the world. You can look in on what your system's doing. Basically, the GX device, the Servo GX or Chrono GX, it's going to be hardwired to all your chargers and loads and everything. And so whatever is hardwired to it, the GX device itself is connected over Wi-Fi or cell towers to the internet, and it's going to upload everything that the system is doing. I think the Renogy One, they also have a system that will do that and upload to the internet. But yeah, the Bluetooth is it's just so you can have a wireless, you can check on your phone or tablet or your laptop and have a wireless look at what it's doing. For Victron, that would be the Victron Connect app. The only other thing for Bluetooth is the sensors. So like the RUVI tags for temperature and humidity, they will use the Bluetooth signal of the Servo GX or Chrono GX. And then the Mopica ProCheck sensors for water or propane tanks, they'll also use the Bluetooth LE, so it's Bluetooth low energy. And the Servo or Chrono will pick up the signals from those sensors. So you have to have less hardwired sensors. But all the other chargers and battery monitors, they all have to be hardwired. They will not tie in over Bluetooth to the central monitoring device, Servo or Chrono. So hopefully that was not too Victron specific, but that's kind of how it all works. Number 25, how to properly wire the BMV 712 or Servo relays for low temp cutoff on LiFePO4 batteries lacking low temp cutoff BMS. So they mentioned the BMV 712 and the Servo, they both have onboard relays that are programmable for low battery voltage or low state of charge, high temperature, low temperature, things like that. So you would set up a low temperature alarm to activate that relay, and the relay could control for like your chargers. Some of the chargers have Victron's chargers have an H terminal, so you could have basically it would run through the relay, and when everything was good, the relay would be on. It would send power through to run that charger. When the temperature got too low, the alarm would go off, the relay would switch, it would open up, break the line to the charger would go dead. But I would say in general, your chargers are going to have some kind of low temperature setting, so you won't necessarily have to use the relays on the Servo or the BMV 712. If you're using Victron, you can have the Multiplus can shut down. It has a temperature sensor that comes with it. Just use that, go into Victron Connect and when you program it, and there's a low temperature shutdown setting. It will tell you though, if the battery has a low temperature cutoff itself, it says don't set that setting in the charger. Just let the battery disconnect. I did notice that the other day. I was working on one of my students' vans. He came through Houston, and they want you can just shut the chargers down. On the solar, you can program it to shut down. The way the solar charger from Victron would get the temperature is it would have the VE Smart network, and it would connect to their Smart Shunt or the BMV 712. That device would take the temperature, and then it would wirelessly communicate it to the solar charger. And in the solar charger programming, you would say shut down at 32 Fahrenheit or 41 Fahrenheit, whatever your battery manufacturer recommends as your shutdown temperature. So yeah, I would just get the chargers to do it. Each charger individually, one way or another, can shut down based on temperature, especially nowadays. It took a few years for the temperature shutdown of the chargers based on lithium, but pretty much all of them are being made with some way to do that now. So you may not need the relays on the Servo or the BMV 712. Hope that helps. So number 26 is Prismatic Batteries. I'm not quite sure what the full intention was, but Prismatic Batteries are battery cells that are rectilinear instead of cylindrical. In general, I would say they are more energy dense than cylindrical because you don't have air gaps. You can kind of stack them together. And I would say, I think this question pertains to, should you make your own battery? Should you get individual cells, order them from overseas, and put your own BMS? And I would say, I think that, cost-wise and reliability-wise, I think it's fine. If you're interested in building your own batteries, I think the battery cost for a ready-made battery in a case has come down from various brands. It may not be worth building your own battery now, but I would say if it's something that you're interested in, we all have our own bent and our own way of doing things. I would say I see no issue with building your own batteries if you are interested in doing that. So I'll go ahead and leave it there. Hopefully that was helpful. Number 27, using different battery types for vehicle and leisure use. This is pretty much every vehicle. Your vehicle is going to have a lead acid starter battery, and the leisure batteries in the back nowadays really aren't lead acid anymore. They could be lithium, they could be sodium. There are a lot of different battery technologies coming out now. I guess we need more energy storage than ever. And generally, your rear batteries are not going to match the vehicle battery. The only thing that you have to look for, oftentimes you're going to have a DC to DC charger, and we call it alternator power, but it's really the unit that's in between the starter battery and the rear battery bank. You're going to have a DC to DC charger in that line. That's going to regulate the current, and it's going to increase or decrease the voltage coming from the alternator and engine battery. It's going to adjust that voltage up or down for the rear system. So it's really no problem at all. This is an everyday scenario. Number 28, do you need a main on-off power switch for solar? Some say yes, some say no. I have solar breakers that I use, and they do cut off solar. I have... You kind of want the ability to shut off everything. I don't know why you would have solar and not be able to turn it off, because power is coming in off the roof. If you need to work on the system, you really need to be able to cut that off. If the vehicle's in storage and you don't want the batteries charging, you want to cut off solar. So I would say yes, but I would use solar breakers as my cutoff switch instead of an actual switch. That way you have overcurrent protection and a cutoff switch in one. Just get those DC breakers. I like to use the Midnight Solar MNEPV breakers. And they have a lot of different ratings. Number 29, using an inverter connected to the starter battery / alternator to a multiplus to charge rear system. I kind of get what you're saying. It's going to come out of the alternator engine battery, and it's just going to feed the multi-plus to charge the rear system. In general, you kind of want to go DC to DC, like the DC to DC chargers say. You're coming from DC power on this system, and you want to deliver that as DC power, direct current power to the rear system. And the DC to DC chargers aren't 100% efficient, but in general, if you go to the multi-plus, you are going to be, all you can deliver is inverter power to the back. And then that's 120 volt power or 230 volt alternating current power. And then you would need some kind of rectifier or converter to step that back down to 12 volts. So when you go into the multi-plus from the starter battery, you're boosting the power up to 120 volts, let's say. And then when you get to the back, you need to go to converter 120 volts back down to 12 volts. So you're creating two conversions that don't need to happen. You just need to go DC to DC. Just have a DC to DC converter in there. If that's maybe 93% efficient or 90% efficient, then we're only having kind of one converter instead of two. So hopefully that helps. Don't step it up and then step it down at the rear system. Just go DC to DC, put the multi-plus in the back, pulling off the rear batteries. Number 30, review Battleborn 6500 Power Pack. So I checked this out. It's a brand new, they're calling it a generator replacement. I calculated the watt hours. It's 540 amp hours. It's got two GC3 batteries. It's got a multi-plus that is made for 50 amp RV service. It's got a DC to DC charger. It's got a solar charger, and it's got breakers and switches. It's really a power system in a box. It looks really nice. Top of the line components, top of the line batteries, and Victron components and Victron monitoring. As far as the generator replacement thing, I don't really like that. They're always trying to throw generator. The thing with the solar generator, nothing's gonna produce power like a gallon of gasoline. I actually looked this up, so check this out. The 6500 Power Pack has 6,912 watt hours. If you take 540 amp hours multiplied by 12.8 volts, the nominal voltage of those batteries, you're going to get 6,900 watt hours. They're calling it a 6,500, but about 7 kilowatt hours, right? I checked a gallon of gasoline is 33.4 kilowatt hours. Diesel is between 35 and 37 kilowatt hours, really 37 kilowatt hours. So we have 7 kilowatt hours in the entirety of the batteries in that 6500 Power Pack, and 1 gallon of gasoline has 4.5 times that. A gallon of diesel has 5 times the energy. In 1 gallon of diesel, 5 times the energy that's in that entire 6500 Power Pack. So as a generator replacement, I would say be careful. It's just got 540 amp hours of batteries, and then the rest of your power system. It's a power system in a box with 540 amp hours of capacity. It's a beautiful machine. It looks top of the line for sure. They are showing it as a go green drop-in replacement for a generator, but a generator is going to take gallons of fuel and produce thousands of kilowatts or hundreds of kilowatts, whatever. You're going to be able to have a few gallons of fuel and create like orders of magnitude more energy than what's in that 6500 Power Pack. So as a power system, great. Looks great. Drop-in power system for a van or RV. As a generator replacement in an RV, I would say be careful. So I hope that helps. Number 31, automatic engine start when the batteries run too low, automatic cutoff when the batteries are recharged to a certain percentage or user definable. So this would be something that you would use the relays from a Servo GX or a Chrono GX. You would program it. It's going to get the state of charge of the batteries from the battery monitor, something like a Smart Shunt or a BMV 712. You're going to hardwire that to the Victron GX device, Servo or Chrono, and you are going to program those little relays on the unit to click on and click off relating to certain battery states of charge. So once it's all programmed, you come in there, like you said, user definable. Hey, when my batteries get down to 30%, the relay connects and sends power through. When it gets up to 80%, disconnect the relay and stop the signal going through. So you're going to have a little, probably 12 volt signal wire, and it's going to go to some kind of engine start module, and that is going to be separate, that you would have done at an auto shop or like a car audio shop that installs the remote starts, and it just needs some kind of module that takes a 12 volt signal, and you're just going to generate that signal in the back, run it through those relays, and if the relays connect, the engine start module gets the signal. If the relay opens, then the signal stops getting to the engine start relay. But that's how you would do it. So I gave you a lot of details on how it would be done with the Victron GX device and the Victron battery monitors to set off that relay. But your module in the front, that's going to come down to what engine starter that you have installed and what kind of interface it has to accept a 12 volt signal. But a lot of stuff you can turn it on and off with a 12 volt signal. There's not a lot of current, it's just 12 volts when it's on and 0 volts when it's off, and you're able to turn things on and off with that little signal wire. Hopefully that helped. Let's see. Number 32, new changes for landscapers related to battery power equipment. We need power to charge batteries for this equipment and solar, AC/DC combination on a box trailer or enclosed trailer. Mr. Nelson. All right, so this is a California problem. I've been watching California Insider, and they are getting rid of all the gas-powered lawn equipment, so you got to run everything on batteries. Basically, Nelson, what I would do is figure out how many batteries per day on a full shift, dawn to dusk, how many of these batteries that you want to recharge, and look at the battery and look at the milliamp hours in each battery. Let's say you have 10 batteries, each battery needs to be charged 5 times, that's 50 battery charge cycles. Let's say each battery is 3,000 milliamp hours. It'll say something like that. Or amp hours. But basically get the total. Okay, I have a 3,000 milliamp hour battery, 3 amp hour battery. I need to do 50 recharges. So that would be 3 times 50. It's 150 amp hours of recharging. So you're basically going to have to put that battery capacity in a big battery bank. Connect that battery bank to a 12 volt output. You said AC and DC charging. So DC, you would just go from the battery bank to some kind of 12 volt socket. And then you would connect the battery bank to an inverter that would give you 120 volt output. And you would plug all your chargers into that output. So you could recharge a charger that needed DC power or AC 120 volt power. But basically that battery bank needs to be, you charge that up overnight, and then during the day you just drain that big, it's like a big fuel tank, and it needs to add up to however many little batteries you need to charge during the day. That amount of fuel needs to be in that big fuel tank. So you're just going to charge it up at night, kind of charge a bunch of little batteries off of it during the day. And of course, you're going to have 10 to 15% losses on the inverter, so you're going to need to add 10 to 15% extra battery capacity to your big battery bank. And unfortunately, California power, it's not all clean. A lot of it is coming from, they call brown power from Colorado and other states that are not running wind and solar. So you're really charging off of fossil fuel to charge up your battery, so you don't have to use fossil fuels on your lawn equipment. I will say this though, I think it's going to make competition harder. I think it's going to put a lot of lawn services out of business. So it's kind of weird situation. But I think if you can pull off that charging station, you'll be ahead of the game, and a lot of people aren't going to be able to engineer that. Or they'll just go over the state lines and keep buying the gas-powered equipment, which may be a solution. If it were me, I'd probably do that until I was able to engineer this system. Question number 33, how to set up your system to be able to start your engine with your house batteries in case of an emergency. So I covered this in the recent video series. Basically, you can get a DC to DC charger that has reverse charging, so it's going to trickle charge your engine battery. The Sterlings have the jump start assistance, so it will just send a full current. It'll flip a switch and link your rear house batteries to your engine battery, and all the batteries will crank the engine. If you don't get a Sterling, just in general, you can put a switch below your DC to DC charger. That switch is off most of the time. The positive cables from the front engine battery and the rear batteries, the rear system, they come into the switch, and then they come out of the switch and go into either side, the in and the out port for the positives on the DC to DC charger. And when you turn that switch to on, it creates a bypass that runs right past that DC to DC charger, and it's going to put your rear batteries in parallel with your engine battery, and they are all going to start your engine. And then once the other thing you can do is just turn that switch, and it will level out the voltage between your engine battery and your rear batteries. You're linking them electrically, and you don't have to actually start the vehicle. You can just turn that, and your rear batteries would be a higher voltage, even if they have a charge source like solar, and it'll bring your engine battery up to that voltage. Then you can turn the switch and disconnect it and go ahead and start the engine. So it's a way to just charge up your engine battery, even if you don't jump it. The reason I say that is if you jump it, it's going to send a lot of current through those lines, and it may be too much current for the fuses. If you have a little DC to DC charger with 60 amp fuses, it may pull more than that through those lines and blow your fuses. So you may just want to have that emergency switch below the DC to DC charger and just use it to charge up your engine battery, and then cut it off before you crank the key and start the engine. So hopefully that was helpful. Number 34, cold weather application, battery type carbon versus lithium. The carbon, I studied up on them before this, and I think they are lead carbon is what you're going for. That seemed to be the battery type that I found, and in general, the lead batteries, they just operate to a lower temperature than the lithium. The lithium is going to output power down to -4 Fahrenheit. The only thing is now we're getting a lot of lithium batteries with heaters in them, so they will warm themselves up. The other thing too is if you discharge them, if they're in use, they will warm up. Especially if you're drawing a lot of current out of them, they will warm up pretty quickly. So, but as far as like it's a blizzard outside and the whole system's off and you're going to walk up and turn things on, the lead carbon batteries, as far as I can tell, they will operate down to like -40 Fahrenheit, and the lithium will operate down to -4. So if you're not having active heating and you're not there and turning the heaters on and stuff like that, and you just want to come out of nowhere, the lead carbon batteries will operate at lower temperatures for cold weather. Now, what we've seen with lead batteries is they're not necessarily as strong. The lithium batteries, when they get really, really cold, they'll go down to -4 Fahrenheit, but they'll still output quite a bit of current. With the lead batteries, at least the lead acids, sometimes you see that they get weaker and weaker the colder it gets. So they're operable, but they're not really strong at those super cold temperatures. But as far as like maximum, the coldest temperature, the lead carbon is going to beat the lithium. So I hope that helps. Number 35, plug and play that can be easily moved from one unit to another. So I guess we're talking about an EcoFlow or a Bluetti. We're definitely throwing those brand names. You're welcome, EcoFlow and Blue Eddy. We're throwing those brand names around a lot today. So you would basically have all of your connections in each vehicle. So you would have like your solar panels coming in, and they would just be like an Anderson power pole connector sitting there, and then your wires that went around the vehicle to distribute power, that would be sitting there, and you would just put the unit in there and just plug everything into it. That's what those units have. They just have a bunch of plugs on the face. So you would just have a bunch of pigtail wires just sitting there waiting to be plugged in. And then if you're going to have another vehicle, you would have the same thing. So those wires would be going off to, as I said before, get one of these all-in-ones that has the DC to DC charger. So you would have wires running off to the alternator with maybe an Anderson power pole connector just sitting there. You would have the solar connector just sitting there. You would have, if you had a breaker box where you had branch circuits running around the vehicle, you could have a main line that was sitting there waiting to plug into the all-in-one. So basically all that infrastructure would be in each vehicle, and then just like the brain, the main power plant would be moved, and you would just put it in place, maybe have like a lashing strap where you tie it down and just plug everything in, and it would just light up your world, light up everything. And the other thing would be shore power. Maybe you have a shore power inlet on the outside somewhere, and that runs in. It has a little plug that's waiting to go into the all-in-one. So hopefully that helps. Number 36, overview of some projects and full diagrams of standard projects, most common van conversions. So this was requested for the video series that I did. In general, full diagrams and all that, I put that in my paid program. I have, like, my cheat sheet has a nice overview diagram, but in general, full systems diagrams, I don't really give those out for free, other than my whiteboard trainings, I draw systems, but for specific systems, they need a parts list. That's kind of the thing that goes with it. And then oftentimes if I give you the system, there's going to be questions on programming or what's this part. Now I'm doing, when I have my systems in my master class, I'll do the diagram, the parts list, and then I have been doing an overview video where I spend time going through them and explaining everything. So it just answers a lot of questions that way. But in general, just giving out diagrams. Some of the vendors, some of the dealers of like Victron equipment, they try to give out diagrams. Battleborn will they'll make diagrams for you. But I find that there's details missing. Sometimes there's things left off, or you need to make a change, or there's no parts list for all the little parts and connectors. So it's just something I don't try to me, that's electrical engineering. I don't really try to give that away. I sell it, and if people don't value that, then that's okay. Number 37, sizing batteries to inverters. In general, I would just say your inverter is going to take, let's say they want a 400 amp fuse. That would be kind of a maximum amount of power. A lot of them will tell you in the manual how much battery capacity they want for that particular inverter. But if you had to guess, if they ask for a 400 amp fuse, I would match that to a battery bank that can put out 400 amps. Now, if you have little batteries that put out 100 amps each, their BMS limits their output, you would have 4 of those. So you would have a 400 amp output to match the fuse of the inverter. That would be pretty safe, because typically the fuse rating of the inverter is going to be like a maximum, like a surge, and it's not going to take that amount of current on an everyday scenario. Like if it asks for a 400 amp fuse, it's never going to go up to 400 amps. So if you can match the 400 amp fuse to 400 amps of output from your battery bank, I would think that would be a good match. But the other consideration with battery banks is it's a fuel tank. So you need to add up your loads and figure out how much fuel you're using each day. So that would be like watt hours or amp hours. You multiply the watts or amps that each appliance takes times the number of hours each day, and multiply those together, and then add up your list. And that's your total amount of energy that your battery bank needs to have. So it could be amp hours or watt hours. And that's really the main way you're going to size the battery bank. But so that's a couple ways to come at it. But hopefully that was helpful. So that is it for the Q&A. Thank you so much for watching. I hope that was highly valuable for you. Again, if you'd like a copy of the Ultimate Van Power Cheat Sheet, all you have to do is click that link below or go to rosslukman.com/vanpower. So thanks for watching, and I'll see you in the next video.